I think to begin with, the students are asked an open-ended question. So there's no right or wrong answer, there's no yes or no. And in order for them to conduct the experiment, they have to sort of understand what they're trying to figure out. So to connect friction with ease of motion, in our lesson plan anyway, the kids have to choose different materials, find a way to attach them to the shoes, attach a rubber band to the shoe, and then they've got to be able to pull that rubber band to measure the ease of motion. Once they collect their data, they've got to find an average, plot it on a graph, and then use that information to tell what the connection is between ease of motion and the shoe sole materials.
In this lesson, the students are going to learn how to relate friction and ease of motion, and that as friction increases, the ease of motion decreases.
Let's try this. Let's see if the shoe will move with this.
Most students have a basic understanding of friction, and most teachers just tell their kids that friction is two things rubbing together. They rub their hands and that's it. But to connect friction with the ease of motion is the piece that I think that most elementary students anyway are missing.
Our group had noticed in the past when working with friction in this content area that students had a hard time relating when the friction and ease of motion just in answering questions and discussion, and we felt that it was a simple place to start. Even though it's easily confused, it would be a very simple lesson to begin with. The students are going to view a video of Michael Jackson doing the moonwalk and going to get a chance to try doing the moonwalk in the classroom, and then they will journal about how they think he was able to move so easily across the floor. From there, the teacher will present the investigation question, which is, what is the relation between various shoe sole materials and the ease of motion?
And then the fleece slides next because it doesn't have as much resistance as the paper towel.
This one, but if we just decide too hard and it sticks to
it sticks.
It's like sticks, and then it really won't budge. This is really slippery, but it just breaks easily.
Some parts of the experiment they'll have to design themselves, so they'll work together in their team to choose some shoe sole materials to use and an apparatus to pull the shoe across the floor and measure the stretch of a rubber band based on different shoe sole materials. Then they will gather their data and average it and graph it, and in the end analyze it together as a class.
And see, we're going to attach it right here to the laces.
To the laces, okay. And so where are you going to start your measurements? From the end of the rubber band? Oh, you're using two paper clips.
Because we thought it would be easier. And you don't have to hold on like this, so it's actually better. You can actually test it a lot better.
It's definitely inquiry. We're basing it on a question. The students have to design an experiment to answer their question, and then they're using their actual data to answer the question, not just what they think.
You could actually see the difference once you marked it, so you could actually see like which was better, and you couldn't just sort of think that it was better.
I think it's a STEM lesson. We include a lot of science SOLs, so for grades 4, we're definitely dealing with friction, and then for grades 3 through 5, we're dealing with conducting an investigation, collecting and interpreting data. As far as technology, the kids aren't using much of it. It's mostly teachers using technology, but we did put in an enrichment for the kids to be able to look at the experiment videos through iPads or iPod Touches. In terms of engineering, they've got to design a way to conduct this experiment, and then when we're talking about mathematics, not only are they creating a bar graph, but they're collecting data, they're averaging numbers together, and they're measuring using centimeters.
They're going to measure the distance that the rubber band stretched before the shoe moved, and then they will have to average their data from their trials and plot that on a bar graph, and then they are going to be exposed to probably a new form of data analysis by combining all of the group's data into a scatter plot. And so they'll then look at the scatter plot and see what that tells them about the relationship between the shoe soles and the ease of motion. One of the challenges that the students might come upon is the math involved in averaging the data. Based on where you are in your math curriculum, you may have to provide more scaffolding for helping them to average and then round appropriately. Another place where you may provide scaffolding or even enrichment is how carefully you want them to measure. They can measure to the nearest centimeter, or you can provide an extension by encouraging them to measure to the nearest millimeter.
The completed Wordle includes all of the words from your writing, from your journal, and from your observations.
I think probably the Wordle part. If you're not familiar with using a Wordle, the more often you type a word into the program, the larger it appears on your finished product. So as the teachers are having discussions with their students, if one word gets repeated, they're going to want to type that in repeatedly to make sure that it draws the student's attention when they're done. I think probably also at the end when they're making the scatter plot, if teachers not familiar with the scatter plot, they're definitely going to want to make sure that they understand that before they start the lesson.
I think there's a lot of opportunities for error analysis discussion in this lesson. This was actually my favorite part of implementing the lesson in my class. We got to the end when we were plotting all of our data as a class, and one group had very different data from the rest of the groups, and so I put forth the question, why did this happen? Why is this group's distances so much different?
Why is it that this team has these such low numbers for these things that the other teams got such high ones for?
Maybe they use the light
Maybe
shoes.
because they use. What is the answer?
I know because I was on that team. Because we didn't use the water bottle as the weight.
What'd you use?
The pink towel.
Yeah.
One thing that seemed very small at the beginning turned out to be make a big difference in their data, and so we learned a good lesson about keeping constants among all groups.
That tells me that those pieces of data are pretty accurate.
I think the lesson was successful, but for me the most surprising part was I got more information from the kids' written assignment than from the actual fill in the blank and circle the correct choices. So when they actually had to use words from the Wordle in a paragraph that supported the answer to their question, that really told me whether or not they understood what friction was. With my fourth grade students, I find that they've become a lot more curious when it comes to math and science. So instead of looking for one end answer, they're actually asking questions now. They're drawing models in math. Before they learned how to divide to do the averaging part, some of the kids tried to figure out a way to divide without using the calculator. So there's a lot more questions that have come up from this lesson that I couldn't have asked the kids myself. The kids learn by the time they're done with this lesson that science isn't real, there's no really end to it. Once you come up with an answer to your question, that's bound to spark other questions to keep you on going.
What was the third one?
Tinfoil.
8.